Example 25. Find the horizontal thrust of the water on each meter of width of the sluice gate shown. Assume ideal flow. So this is the figure. So this is the hydrostatic pressure diagram for the left section. Call the force as F1 and the right section here as F2. Then the force that will hold the sluice gate in place, R. So V1 equals Q over 1 meter width times depth 2.1, so 10Q over 21. V sub 2 on the other hand is Q over 1 times 0.36, so it is 25Q over 9. Then energy equation between 1 and 2, neglecting head loss because the flow is ideal. So velocity head at 1 plus pressure head 0, elevation head 2.1, the floor, equals velocity head at point 2, 25Q over 9, quantity square over 2G, 19.62, pressure head 0, then elevation head 0.36. Simplifying, 1.74 equals 0.3817 Q square. So from here we can compute Q, 2.25 cubic meter per second per meter. Then F1 is specific weight barred H1 area 1. So 9,810 newtons per cubic meter. Barred H1 is half of 2.1 because the section is rectangular. Then area 1 is 1 meter by 2.1. So 21,631 newtons. F2 is 9810 times 0.36 over 2. Area 1 times 0.36. So 65.7 newtons. Substitute into summation forces X equals Q rho quantity V2X minus V1X, where V2X is just V2 and V1X is just V1. So F1, V1 by the way is 10 times Q, which is 2.135 over 21, so 1.017 meters per second, and V sub 2 is 25 times 2.135 over 9, 5.931 meters per second. Then substitute here F1 to 1631 minus F2 minus R equals Q, density 1000, quantity V2X 5.931 minus V1X 1.017. So R equals 10,504 newtons, so it is directed to the left as shown, but the horizontal thrust of the water on each meter of width of the sluice gate is equal in magnitude but opposite to this value. So it is rightward, 10,504 newtons rightward.